review of stuff that we already did. Must have hit the wrong button. There it is. So let's look at, let's say we look at F together. So F has square root of 72 times x to the fourth times y cubed. So how should we attack that one? Say it again. Which would be the third? Or did I say the wrong thing? Say it again. The factor tree thing, yeah, for the 72, we probably should do that one, yeah. So how can we break apart 72? Eight and 9 work. We can break 8 down into 4 and 2, and then the 4 can get broken down more in 2 and 2. How about the 9? 3 and 3. And then again, since we're doing square, we look for pairs, right? What do you see pairs of? Yeah, a pair of 2s and a pair of 3s, right? So out in front of the radical, we can put what? 6, the 2 times the 3. Good. And under the radical, there'll be what left? A 2, right? This is odd man out, if you will, right? So that takes care of the numbers, or the number. Let's take care of the variables as well. How about the x to the fourth? What can you do with it? X squared. Maybe an x squared. Are there any x's left over underneath? No. Good. What about the y? Is the extra y. Good. The y, there's a y squared in there, so we can pull out a y, and then there's an extra y left over underneath the radical. Good. Is that okay? Like I said, that looks like one you did on the quiz, right? And the quiz went pretty well overall. So. Is that okay? Like I said, I'll leave those other ones for practice, but let's do a couple other ones here. Let's look at part B here for number 2. So this one's just asking us to simplify this with numbers. And basically it's just asking you to remember what the fraction exponent means. In particular, what does that number in the denominator tell you to do? It's a fourth. The root, yeah, the fourth root, right? Remember the number in the denominator and the exponent tells you what root to take. And the number in the numerator tells you, yeah, the exponent, the cubed, right? So we want to do the fourth root of the 81 over 16 and then raise that answer to the third power, all right? So let's see how we get a fourth root. I think factor trees help with that as well, personally. If I look at 81, what things multiply together to give you 81? 9 and 9, and then we can break each 9 into 3 and 3. And since we're doing fourth roots, how big of a group of things do we need to see in order to pull it out in front? 4. That's exactly what we see here, right? So the fourth root of 81 will be 3. Yeah, it's for the 16, it's just a 2, exactly right. Again, if you like factor trees, 16 is 4 times 4, and each 4 will break up as 2 times 2, and there's a group of 4 again. So now this says do 3 halves to the third power. What do you get when you do 3 halves to the third power? 27 over 8. Good. Yep. 3 cubed is 27, and 2 cubed is 8. So we get 27 over 8 for that one. Again, the big thing to remember when you're simplifying problems like this is that denominator is telling you what root to take, right? The other number tells you the power. So if you're looking at the part A, which was just, it's saying it's 25 to the 1/2, what is that telling you to do? What is that 25 to the 1/2? What is it telling you to do? Yeah, the square root of 25, right? Which is 5. Yep, that's all that one's asking you to do. Is that okay? My goodness. Sorry. All right. So the other ones are asking you to do the same thing with the exponent here to change to a radical notation. So we just did that for part B. So let's look at part B of this next one. Before we do anything, I've got x to the 1/3 times x to the 1/4. So what do you do with the exponents here when you multiply? Yep, we're going to add them and find a common denominator, right? Remember when we multiply, we add exponents. So to be able to add 1/3 and 1/4, we need a common denominator. What are we going to use for a common denominator? A 12. So I would multiply the 1/3 by 4/4, multiply the 1/3 by 3/3, or use your calculator, right? Okay. Again, if you don't know how to use your calculator to add fractions, come see me. I can show you how to do it. Can save a lot of heartbreak or heartache or whatever you want to say. So what do we get for a final answer there? So when we add those together, we get 7/12, right? And again, this one's asking you to convert it to a radical notation, right? So again, the 12 on the bottom tells you the root, right? So you'll get the 12th root of x to what power? The 7th. Now again, it doesn't matter if you put the 7 on the inside or on the outside. Either one of those works. They mean the same thing. You do either or. But again, the big thing here is that the denominator tells you the root, the numerator tells you the power, like it always does. Does that make sense? Pardon me, goodness gracious. All right, so let's do one of these where we're simplifying some things with exponents again, just to make sure that we're all on the same page. You want to do C or D? Which one would you rather do? D? Okay. We'll do D first. We'll do D. Okay. And again, I'm going to leave the rest of these for you for practice. So I think the first thing I would do is work with this exponent up in the numerator. I've got a product here and an exponent here. What can I do with this exponent relative to the product here? You can distribute it to each piece, right? Okay. So I'll write it out in steps. You could do this in one step. I'm going to do it in two. In particular, just to remind what this means, I've got x squared, and I raised the whole thing to the 1/4 power here. What do you do with the exponents in this situation? We multiply them, right? We multiply those two together. What do you get when you take 2 and multiply it by 1/4? You get a half, right? So we'll have x to the 1/2, y to the 1/4, x to the 1/4, y to the 1/2. Again, if you went from this step directly to this step, that's okay. I just wanted to make sure I reminded about this property here. Now we've got x to a power on top, x to a power on bottom. What do we do with the exponents when we divide? Yeah, we subtract them, right? So we would have x to the 1/2 minus 1/4. What power would y be raised to? A fourth minus a half, right? We got to do, it's top minus the bottom, right? Top exponent minus bottom exponent. So x to the 1/2 over x to the 1/4, y to the 1/4 over y to the 1/2. So we're doing 1/2 minus 1/4 on the x, 1/4 minus 1/2 on the y. Fine, we have two more steps here. 1/2 minus 1/4 is equal to a fourth. And if you do 1/4 minus a half, you get the other way around, but it's negative a fourth, right? Yeah. When you do 1/4 minus half, you'll get a negative 1/4. And the problem says, write your answer. Yeah, Bryson. What makes it negative? Yeah. A half is bigger than a fourth. You would have 1/4 minus 2/4 when you subtract it.
Oh, okay.
You see what I mean? So it'd have like that. And so so it'll be negative. The problem asks you to rewrite all your answers without negative exponents. Only use positive exponents. So what do I need to do to write this with positive exponents now?
If your negative tells you your location, wouldn't be x 1/4 over y.
Good. Exactly right. Yep. So the negative tells you to flip it, right? If it's on top, move it to the bottom. If it's on bottom, move it to the top. This one's on top, so we flip it to the bottom. So you have x to the 1/4 over y to the 1/4. Okay? So again, I'll leave this for practice. The answers posted to these on Moodle. Okay, so if you want to do it for practice and check your answers, or come see me if you want me to go over them with you. Happy to do that too. Let's go ahead. What were you going to ask?
I was asking if you would show up.
Oh, sure. Yeah. I'm going to hand out some papers. So. All right. So we're going to play some more with radicals, actually for the rest of the chapter. But today we're going to do some operations of things that have radicals in them. In particular, we're going to add expressions that have radicals, we're going to subtract them, and we're going to multiply them. Yeah. Say again? A loner? Go to student success. I'm pretty sure they have some. Oh, that's not good. I think student success has some that they know. So I would go over to the UCF. I think they do. All right. So we've already talked about. We've already talked about how we add, subtract, and multiply polynomials. We're going to do radicals in the same way. Remember when we added like terms and subtracted like terms for polynomials? We're going to do a similar thing here with radicals. And I'll probably still use the words like terms. I think Hawks uses explicitly the expression like radicals. So when you have like radicals, that just means the radical parts match. So it has to have the same index. So if it's a square root in one of the terms, it'll have to be a square root in the other one. So if it's a square root and cube root are never like, right? They're different roots. Okay? It also has to have the same radicand, or what's under the radical. So the example there that's on your sheet has 2 square root of 3 and 5 square root of 3. Those are like radicals. Okay? They have the same square root and the same 3 under the square root. Okay? Just like 2x and 5x would be like terms. Same idea. Okay? Same concept. So if you go to add them or subtract them, we would add them or subtract them just like we did for 2x and 5x. This, we would just treat the root 3 like it's the x, and we combine them. If you added them, you get 7 root 3. If you subtract them, you get negative 3 root 3. Okay? You do them exactly like you do with polynomials. And we're going to do several examples, but that's how we do these things. Sometimes, though, we have to simplify things so that we can see whether or not they are like radicals. So let's look at this example, where we have square root of 50 plus square root of 32 plus square root of 12. Let's simplify them. So let's look at the square root of 50 first. If we break these down using factor trees, what multiplies to give you 50? Yeah, 10 and a 5. 10 can be broken down into 2 times 5. Do you see a pair of things? 5, right? So we can rewrite 50 as what? 5 times the square root of 2. Does that make sense? How about 32? 8 and 4. 8 can be broken down to 4 and 2, all right? And then 2 and 2 for the 4 and 2 and 2 for the 4. What pairs do you see? I got a pair of 2s and another pair of 2s, right? So how can you rewrite the 32? 4 times square root of 2, right? You have the pair of 2s and the pair of 2s, or does it make a 2 times 2, which will give you a 4? Finally, what about the 12? 3 and 4. And then 2 and 2. And how does that get written? 2 root 3. Good. Everybody see how those got rewritten? That's not anything new, right? This is stuff we've already done. Okay? All right. So now, do you see any like radicals? Like, do they be like terms? Do you see anything that are alike? Yeah, the 4 root 2 and the 5 root 2 are like radicals, right? So again, if I think that this is an x and this is an x, I can add them together. It'll be a 9x. So that's going to give me what when I add those two pieces together? 9 root 2, good. And then 2 root 3. Those are not like radicals, so I can't do anything with them, right? Just like if you had a 9x and a 2y, I wouldn't be able to combine them. So it would be as good as it gets. Does that make sense? All right. So this is how you would add or subtract. Simplify your radicals. See if you've got like radicals and combine anything that is like. Just like you did with polynomials. We're going to do a similar thing with multiplication. The only thing that's different with multiplication is we might be able to combine some radicals. So I'll just go through some examples, but rather than going through a lot of words. But if I look at this first example on the left with the polynomials, what would you do with the 5x? You would distribute it to each piece, right? You would end up with what when you distribute it? Good. 10x squared minus 5x. And notice what you really were doing there with the 5 and the 2, you multiply those together, you get 10, the x and the x, you multiply together, you get x squared, right? Combining those kind of things together with multiplication. We're going to do a similar thing with our radicals. When you take the 2 root 3 times the 4 root 5, your 2 times your 4 would give you 8, just like the 5 times the 2 did over here. When you do the root 3 times the root 5, we can actually combine those two things together as square root of 15. You can just multiply the radicands together. Yep. So what would you get when you, for the second term in that, when you distribute? Yep, 6 times square root of 21. That's exactly right. Yep. That's okay? Yes. Yep.
So you can either square times the square times the whole.
Yep. Yep. When they have the same index, right? If this were a cube root of 5, then I wouldn't be able to combine them that way. So far, so good? Okay. Now, the only thing that might be a little bit an extra step here would be as if when you can multiply these things together, you can actually simplify what's under the radical. Okay. Like, for example, if you had square root of 3 here and square root of 15, let me just do it off to the side rather than talk about it. If you had something like square root of 3 times square root of 15, like that, that would be square root of 45, multiplying your 3 and your 15 together. But notice that your 45 has a pair of 3's in it. And we can simplify it. So it might be the case that when you multiply radicals together, you can simplify your radical afterward. So just watch for that as it goes along, is all I'm saying. All right. Let's look at the next example here. We have, if we look at the polynomials, remember that we would do what here if we're going to multiply these together? You have to distribute everything to everything else, right? So we would get what when you multiply those things together? You have 3x times 5x gives you 15x squared, and then negative 12x plus 10x minus 8, right? Remember doing all those distributions, right? Right, we did the 3x to the 5x, the 3x to the 4, the 2 to the 5x, and the 2 to the 4. That's familiar stuff, right? And then when we're done, combined like terms, correct? Okay. We're going to do the exact same thing with radicals. So what do you get when you distribute out the radicals here? Good, 6 root 15. Okay, there was a 12 root 5, right? Because we'll do the 3, that whole thing. Yeah, and then minus 10 root 3, and then plus 20. Yeah. So multiplying like we did before, the 3 root 5 times the 2 root 3 will give you 6 times square root of 15. The 3 root 5 times the 4, well, there's no root attached to the 4, so we'll just multiply the 3 and the 4 together. Like what we did here, right? When we did the 3x times the 4, we just multiply the 3 and the 4 together. Same idea. Minus 5 times 2 root 3 will give us the minus 10 root 3. Minus 5 times minus 4 gives us 20. Are there any like radicals here that we can combine? Nope. And 15 doesn't break down anymore, right? It's 3 times 5. There's no pair of anything. So this is as good as it gets. All right. So let's work on some problems here together, and then I'll turn you loose on a worksheet that I have here for you too. Okay. All right, let's look at this first one. Do you see any like radicals? Yeah, the root 2x, right? So what do you get when you combine those two things together? Good. And then plus the 5 root 7 just stays there. And that's all we have, right? Nothing else we can do. Nothing else we can break up is radicals, and certainly root 2x and root 7 are not like. So we can't combine them. So that's as good as it gets. What about the second one? What should we do first? Right now they don't look like they're like, right? Okay, so what should we do first? Yep, trying to simplify them, yeah. Good. How does 125 break up? 25 and 5. And then that's already a perfect square, but if you need to, go ahead and break it apart. So how does square root of 125 simplify? 5. Root 5, good. Notice I've got a pair of 5s and 1 left over, so it'll still be under the radical. How about 20? Yeah. Good. So the root 20 by itself will simplify to what? 2 radical 5. Good. But notice that there's also still that 3 hanging out in front, right? The square root of 20 all by itself is 2 radical 5. There's still the 3 in front. What about the 27? Good. The 27 is 9 times 3. And then the 9 breaks down as 3 times 3. So 27 is the same thing as 3 radical 3. Ooh, did we fall? That was loud. All right. First, how would this now simplify here, the part that I'm underlining? Yep. So we just get 6. Good. Good. That just simplifies to the 6 radical 5. And then finally, do you see a pair of like radicals? Yep. So what will we get there? 11 root 5 minus 3 root 3. That okay? All right. Let's look at one here with 1 or 2 here with some variables in them. Again, first thing we should do is what? Simplify, right? Simplify first, each individual term. Okay? Let's work with the 32. What multiplies to give you 32? 8 and 4. 8 is 4 and 2, and the 4 will give you 2 and 2, and that 4 will give you 2 and 2 as well. So what does 32 simplify? Does root 32 simplify to? We got a pair of 2's, and another pair of 2's will give you 4, and under the radical will be a 2, right? You get 4 root 2. What about the x cubed? Yeah, so your x cubed is there's an x squared in there, so what will pull out? An x, yeah, and then underneath will be another x, right? Still? Yep. And then what about your y squared? Y out in front. Anything under the radical left? No. Good. A y. Right? Because if I write x cubed, that's x times x times x, right? So there's a pair of x's, so we would pull one out in front, and there's one left over. Is that okay? What about your 18 times x squared times y to the 4th? 3 and 6, good. And 6 is 3 and 2. So what do we get left when we simplify root 18? Good. 3 root 2, good. How about your x squared? Just an x, and your y to the 4th. Y squared. Any variables left under the radical? No. Last one. Looking at the 50. 50 is 5 and 10. 10 is 2 and 5. So that's going to simplify to 5 root 2. Good. What happens with your x cubed? An x out in front and an x under the radical. Good. Right? Because it's x times x times x. So the pair of x's will pull out to a single x out in front. And the y squared becomes a y out in front, right? Are we okay with those simplifying? That's just like what was on the quiz, right? That's not anything different. The only thing that's new today really is just, now we've got like radicals. What are your like radicals now? And the root 2x, right? These two are, right? So what do you get when you add or subtract those, I guess it is? So you got a 4xy root 2x and a 5xy root 2x. What do you get when you combine those? Subtract them, yeah. Yeah, that's exactly right. There's just one negative one of them left, right? And then the other one will be 3xy squared root 2. Because it's not like anymore. Notice the root 2x and the root 2 are not like, right? So we would not combine those. All right, let's do this last one. And then, like I said, I got a worksheet to set you loose on here. What do you get when you multiply those things together? $12 times square root of x squared. Good. Remember? When we multiply the radicals together, the square root of x times square root of x will multiply the insides together. So we've got 2 times 6 is the 12. Root x times root x is root x squared. What else do you get? My 6 square root of xy. Good. And the other one? Good. And good. Exactly right. Everybody okay with those? Okay, well now let's simplify. What's square root of x squared the same thing as? Yeah, it's just an x, right? Good. Just like what we did before, right? There's a pair of x's under there. When we take the square root, we just get a single x, don't we? What about the middle two terms? Are those like radicals? So what do we get when we combine those? Good. Negative 36 square root of xy. And finally, square root of y squared is just going to be y. Good. And so there we simplified it. What questions do you have?
Can you go up so I can see on Twitter?
There?
Yes.
Okay. Like I said, here got some practice problems here for you. Holler at me when you got questions. I'll get answers projected up on the screen. I guess you need to. Not up here. We haven't got maps. We don't have it up here. Sorry. I don't even have anything with me. Ooh. Bless you.